Hello everyone, in this video we are going to learn another method of setting out of a simple circular curve. In previous video we have learned a method by which we have taken the offset from the long chord, but in this video we are going to learn setting out of simple circular curve using deflection angle method. So let's discuss the deflection angle method. We know that the basic data, the deflection angle and radius of the curve for a simple circular curve is always known to us. Let's say that this is the point where the back tangent and forward tangent is going to cross each other, the point of intersection. And we know that there's a point where the curve is going to start, that is point of commencement. So joining them together, we will be having the back tangent. Since the deflection angle is given to us, using any instrument that can measure horizontal angle, we can have the forward tangent. And once the basic data is known to us, then we can have the tangent length and ultimately the point of tangency. And also we can draw the center of the curve as the radius is known to us. And there's another line which is in between PC and the PT, which is long chord. Now let's discuss how the deflection angles would be calculated and how they can be used in setting out of the simple circular curve. So deflection angles are actually the horizontal angles, and whenever there is a horizontal angle, there should be an instrument with the help of which we can measure the horizontal angle. And in this case, let's say we are taking a theodolite. As PC is the start point, so we are going to place the theodolite at PC point. Now the point of discussion here is how we can calculate the deflection angle. The formula for the deflection angle is 90L over pi r. So in this formula, L1 is actually a peg interval and R is the radius of the curve. Now L is a peg interval and that is to be calculated depending upon the length of the curve. So we know the formula of the length of the curve, which is pi r phi over 180. So this will involve radius of the curve and deflection angle. So using this we can calculate the length of the curve, and let me tell you that length of the curve is actually the distance from PC to PT measured along the curve. Now once we have calculated the length of the curve, depending upon that we can decide the peg interval. Now peg interval is to be decided in such a way that we can have the maximum points on the curve so that a curvature can be formed. Let's say that we have calculated the length of the curve and that came out to be 100. Now it depends how many points we want on the curve, we can decide the peg interval. Like let's say that we want 10 points or 9 points in between PC and PT, then we are going to decide the peg interval as 10. Similarly, depending upon your value, you can decide any peg interval. Now once the peg interval is being decided, now we can calculate the deflection angle. And let's say that we have calculated the deflection angle and that came out to be any value which is being shown on this sketch. Let's say that this is the deflection angle that we have calculated using this formula. Now what we are going to do, using the theodolite, we will first point it towards the PI telescope and then we will mark the horizontal angle as 0. Then whatever is the deflection angle that is calculated using this formula, we will tilt that amount of telescope rightward by this magnitude. So then we can point out the direction like the one which is being shown on this black line. Now how we can mark the point on the curve? So now we know the direction and we also are familiar with the peg interval, so we can mark the distance as L1. Let's say the distance is up to here, the one which is being shown with a black dot. So then this point can be marked and this point will be the one which is on the curve. The peg interval is usually constant, but again it depends upon you. You can vary the peg interval, but once you are keeping the peg interval constant, then your calculation will become easy. Let's say we are moving forward with the same peg interval, then we can mark another point on the curve by taking the same peg interval L1, and once we are going to calculate the deflection angle, so that will be another deflection angle from this black line. But in order to keep things simple, let's multiply deflection angle with the 2, then we can have the same magnitude. Now we will be having a benefit of doing this. Benefit is we don't need to change the station point. The station point would be same, that will be PC. So once we have the twice of the deflection angle, now we can point it again with the help of a black line. Now we can mark another point, and that point would be a distance of L1 from this point, not from the start point, from this point and on the curve. So let's say this is the point. So this distance and this distance are same. So now we have marked 2 points, and those 2 points are the points on the curve. Now let me tell you that you can also do in this way, that placing the theodolite over here and doing the same that we have done with the previous point. But that will be a very difficult job. You know that shifting the instrument is a difficult job, and that will also consume more time. So in order to save time, we are actually adding the deflection angle with the previous one. The same can be done for the next point as well. Like we can have the 3 times the deflection angle, and that will be this deflection angle. And again we can point out from the theodolite as the one which is being shown on this black line, and again we can mark the point on this black line with the help of L1 distance from the previous point, this point. So then this will be the point. So all these angles are actually being measured from PC to PI line, because we made it to 0 when we have started from the first point. Moving on further, we can have the 4 times of the deflection angle, pointing it towards that. Again we can have the 4th point, and again that will be the distance of L1, the peg interval from the previous point, which is this one, and that point would be over here. So now you can see there is a formation of the curve. Similarly, 5 times of the deflection angle, repeating the same procedure. 6 times of the deflection angle, 6th point. 7 times of the deflection angle, 7th point. 8 times of the deflection angle, and 8th point. Now the last point is not necessary to be equal to L1, because we are calculating the length with the help of this formula, which involves y, which is actually have not exact value, that has a value of 3.14. So we are always going to get the length of the curve in decimals, and we can convert that into the exact number of peg intervals. But again, when we are dividing the length of the curve in equal distances, then we are going to get a peg interval in decimals. And once we are getting a peg interval in decimals, then to keep the same distance on field will become difficult, because that will have decimal values, and to measure the decimal values with the help of tape, if you are carrying that, so that will be a difficult job. So that's why most of the time what we are going to do, we are actually taking a whole number. That could be 5 meter, that could be 10 meter, any whole number. So we are usually taking that whole number. So once we are using that whole number, then at the end we are not going to have that whole number. So let's say that at the end we are having a L2 distance, the last distance. So for that we need to calculate the deflection angle, the last deflection angle, using the same formula, but in this case we will have L2, and that is actually the angle between this line to this line, this angle. And since our instrument is at that point, so we need to have an angle from this line to this line. So that can be measured by adding 8 times deflection angle 1 with the deflection angle 2. So this is total deflection angle, a deflection angle 1 plus deflection angle 2. And if we have done our calculation correctly, we have one check available. But before I tell you about the check, let me tell you what we have made. You can see by connecting these black dots, we have formed a simple circular curve. And now the check is, when we have this total deflection angle, the angle from PC to PI line to PC to PT line, so this angle would be equal to the half of the deflection angle. So if this is equal to half of the deflection angle, it means we have done our calculations correctly. If it is not, it means there is an error involved in the previous calculations. So this is all from this video. We have learned setting out of the simple circular curve by deflection angle method. In next videos, I'm going to teach you how we can solve an example of setting out of the simple circular curve by taking offset from the long chord, and also by the deflection angle method. So this is all from this video. Thank you for watching this video.